Welcome to Study Loop.
Here to talk about motional electromagnetic forces, or motional EMFs, right? So we're going to do this with our particular problem today that talks about the potential differences created between tracks from a moving train and the wingtips of an airplane as they travel through Earth's magnetic field. So our equation, if you forgot, our motional electromagnetic force, represented by an E, equals the electromagnetic field times the velocity of the moving object times the distance between the 2 points, or the length between the 2 points. So the question you're asking probably yourself is, why is he talking about this when the question asks about potential differences? Because potential differences, right, our electric potential differences is also equal to our electromagnetic field, our voltage length, or velocity, times the distance between points A and B. So in fact, VAB equals our motional electromagnetic force. So part A, right? Part A is asking you to calculate the potential difference between the tracks as a high-speed train travels over them. So first, our electromagnetic field of Earth, they give this to us in the equation, is equal to 0.5 Gausses. Now, we have to convert this to Teslas just so our units are good. So one Tesla is equal to 10,000 Gausses. So what this means, right? What this means for us, if you do this, it'd be 0.5 Gausses times 1 Tesla for every 10,000 Gausses. So this means our electric field, our magnetic field, excuse me, our electromagnetic field is going to be 5 times 10 to the negative fifth Teslas. Let's make this G a little bit better. So the next part that we have to talk about is our velocity. The train is moving at 180 miles per hour. So we have to convert that to meters per second. To do that, we're going to multiply 180 miles per hour. So we're going to multiply this by 1609 meters per mile over 3,600 seconds per hour. And what this is going to do is this is going to convert it to meters per second. So then our length, which doesn't require any conversion at all because it's already in meters, is 1.5 meters. Remember, this 1.5 meters represents the distance between the tracks that the train is moving over. So our full equation, if you plug it all in, is going to look like this. Our potential difference, or emotional electromagnetic force, is going to be equal to 5 times 10 to the negative fifth Teslas multiplied by our velocity. So remember, this is our electromagnetic field. This is going to be our velocity, which is 180 miles per hour times 1609 meters per mile over 3,600 seconds per hour. Right? That was our velocity. And we're going to multiply this by our distance between the tracks, which is 1.5 meters. Right? So that's going to give us a potential difference in emotional electromagnetic force of 0.006. right? So this means volts. So this means, guys, that we have a very small potential difference going across these tracks as our train travels through Earth's magnetic field. So this really has no effect on the train because you can convert this down, guys, if it helps you to 6 millivolts. 6 millivolts, right? And you can see that it's just a small potential difference here. So this means that it's too small to affect the train, right? So now we're moving on to part B. Part B is asking us if the maximum potential between the wingtips of an airplane will affect the airplane at all. So we do the same thing. We're still looking at our potential difference or our motional electromagnetic force between the wingtips. So we're still using E or motional electromagnetic force times or is equal to our electromagnetic field times the velocity of the airplane times the distance between the wingtips. So again, our electromagnetic field is 5 times 10 to the negative fifth teslas. Our velocity, remember you have to convert it again, but our plane is moving at 565 miles per hour, which again you have to convert, so you have to multiply it by that 1609 meters per mile over 3600 seconds per hour. And our distance between the wingtips in this case is 64.4 meters. So we plug this all into our equation. So again, that's 5 times 10 to the negative fifth teslas. It's our electromagnetic field. Our velocity of the airplane is 565 miles per hour times that 1609 meters per mile over 3600 seconds per hour times our 64.4 meters. So again, this was our velocity and this was our distance between wingtips. So this is going to give us a potential or a force, emotional force of 0.813 volts. Now, this is a lot bigger than what we had with the train, but we're still talking about a number below 1. So this is still really too small to matter. So this is still, since it's only 0.813 volts, our difference or our motional electromagnetic force, it's not really going to affect the plane at all. So again, this is too small to affect the plane. All right, guys, I hope that helps you out, and good luck to your